Conservation of matter. Matter is all around us. It's in the air we breathe, the ground we walk on, and the food we eat. In fact, anything that has mass and takes up space has matter. And all matter is made up of atoms, which are made up of protons, neutrons, and electrons. And even though these are small particles, they have mass. The matter around us is constantly changing. Some of it's just changing its form, moving from one state to another, like an ice cube melting. But others are changing completely into a new form of matter, with different physical and chemical properties than what they start with. You can see this when chlorine gas combines with solid sodium, and a new substance, sodium chloride, table salt, is formed. During these changes, the atoms themselves don't just disappear, they just rearrange and form into different compounds. And this is known as the law of conservation of matter, which states that matter cannot be created or destroyed, it just rearranges. In the case with melting ice cube, the total amount of dihydrogen monoxide does not change. It just moves from a solid form to a liquid form. Scientists use chemical equations to represent what is happening during a physical or chemical change. The chemical equation used to represent the combining of chlorine gas and sodium to form sodium chloride is represented as sodium plus chlorine will yield sodium chloride, where sodium and chlorine are the reactants and sodium chloride is the product. But there's something wrong with this equation. Can you figure out what the problem is? Remember, the law of conservation of matter states that matter cannot be created or destroyed. And what we see here is that in the equation, there is one sodium on the left and one sodium on the right. However, that little 2 on the Cl shows that there's 2 chlorine on the left, but only 1 chlorine on the right. The chlorines do not match. So we need to balance the equation so that we have the same number of atoms in the reactants as we do in the products. We do that by adding coefficients to the equation. A coefficient is a number placed in front of a molecule or compound that states how much of that molecule or compound we have. This equation now follows the law of conservation of matter. These chemical equations can also help represent the conservation of mass. The law of conservation of mass states that the total mass is the same before and after a reaction. So here's our starting mass, and here's our ending mass after the reaction. In this open system, the starting mass was 73.3, and the ending mass was 72.7. So where did 0.6 grams of the mass go? The mass didn't just disappear. Instead, that mass escaped into the air. If it was a closed system, the gas would have remained in the system and the ending mass would have been 73.3 grams. So since the law of conservation of matter says that atoms cannot be created or destroyed, they just rearrange, and atoms have mass, that also means that mass cannot be created or destroyed, that the mass before will be the same as the mass after.